Chromatography. Column chromatography is a commonly used technique for separating and purifying different components of a mixture based on their physical and chemical properties. Here's a simplified explanation of the principle and experimental procedure of column chromatography. Principle. Column chromatography relies on the differential adsorption and elution of components in a sample as it passes through a stationary phase within a column. The stationary phase, typically a solid material called the adsorbent, e.g., silica gel or alumina, interacts differently with the components based on their affinity for the adsorbent. This leads to the separation of the mixture into individual components as they elute from the column at different rates. Experimental procedure. Obtain a glass column with a stop cork at the bottom. Add a small amount of cotton or glass wool to the bottom to create a porous layer. Add the stationary phase, adsorbent, to the column. The adsorbent should be packed tightly but not too compact. Ensure that the column is vertical and free of air bubbles. Sample application. Dissolve or suspend the mixture to be separated in a suitable solvent. Prepare a small volume of the sample mixture and carefully apply it to the top of the column. Use a pipette or syringe to avoid disturbing the adsorbent. Elution. Add an appropriate eluent or mobile phase, a solvent or solvent mixture, to the column. The choice of eluent depends on the properties of the components and the adsorbent used. Allow the eluent to flow through the column at a controlled rate. Start with a slow flow rate to ensure proper separation. As the eluent passes through the column, it interacts with the components, causing them to move at different speeds. Components with high affinity for the adsorbent will move more slowly, while those with lower affinity will elute faster. Collection of fractions. Collect the eluted fractions in separate containers, test tubes or vials, based on their elution times or when specific components are observed. Monitor the elution process visually or by analyzing fractions using suitable detection methods, e.g., UV light or chemical tests, to identify the desired components. Analysis and evaluation. Analyze the collected fractions to determine their purity and identify the separated components. Use appropriate analytical techniques like spectroscopy or chromatography to confirm